Alright, so now we're going to be talking about set and interval notation. So here we have that the domain of f of x is the set. Remember we said that anytime we see something that has this in the front and the back, that's a set. So the set of all x such that x is between -2 and 5. And the range is all y's such that y is less than or equal to 3. We want to restate the domain and the range of the function using interval notation. So first we're going to fill out this little chart below so that way we can see the difference between interval and set. So in interval notation, if it is equal to, we're going to use a bracket. If it is not equal, we'll use a parenthesis. In set notation, if it is equal to, that's when we've got the line underneath. And if it's not equal to, it does not have a line. Then the circle, if we were graphing it, the circle would be closed. And if it's not equal, the circle would be open. So back up to this first question, it says to restate it in interval notation. So if we're using interval notation, then we're going to need to have brackets or parentheses. So we start with this -2. Let's do domain first. So we know we're going to have the numbers -2 and 5. Those are our beginning and our end. When it is this one, we're using a parentheses because it's not equal. We're not including that -2. And then when it is underlined, we're going to use a bracket. So our domain starts with a parenthesis and ends with a bracket. And our range is a little bit trickier because it is all y such that y is less than or equal to -3. So we're using every single y before -3. So -3 is my stopping point. It's underlined, so I'm using a bracket. I don't know what my starting point is because I'm going forever and going less than that. So if I'm going forever less than -3, then I'm going toward -infinity. Now we've got some problems where we're converting from set notation to interval notation. So we're converting these inequalities. So we want to use interval notation. So we've got x is less than 9. So every x that is less than, not included because it is not underlined, 9. Then on number 2, -4 is less than x, which is less than 5. So we know that our end numbers are -4 and 5. And since neither of these are underlined, then we've got 2 parentheses. X is greater than 0, greater than or equal to 0. So if it's greater than 0, everything has to be above that. It is equal to, so we've got bracket, 0, infinity, and parentheses. So anytime you're using infinity or negative infinity, we're going to be using parentheses. Number 4, x is the set of all real numbers. Every single number, so we're going to write that as -infinity to infinity. Number 5, we've got x is in that set where x is between 0 and 9, and both of them are underlined, so both of them will be brackets. Number 6, x is in the set where x is between 5 and 10, So those are my n numbers. And the second one is underlined, the first one is not. Then we've got convert from interval notation to set notation. So now I want them to look like they do in 1 through 6. So if we are finding values between -6 and -1, they're still my n values. We're just going to say x. And I want my values to be between, and the one with the bracket is the -1. So x is between -6 and -1 with -1 included. Number 8, we've got 6 and infinity. So this is one of the tricky ones. So we're going to say that in relation to x, we've got that we're getting larger and larger and larger. So every x value has to be larger than 6. And this has a bracket, so we're going to say greater than or equal to. Now on number 9, we have bracket to 12 bracket. So x is between those two numbers. And we have brackets on both, so lines on both. Number 10, we have -infinity to 1. So that's another tricky one. So we're going to say x in relation to 1. So if I'm going up to 1, but everything before that if we were on a number line, it would look something like that. And I'm taking up everything over here. So in relation to 1, every number that I'm using would be less than 1. And since this is a parenthesis, we're not going to underline that one. Now on number 11, we have -2 to 3. So those are my end numbers. And if you always write it with x between the two numbers, then you will always have less than less than. And that way all you're worried about is whether or not they have those lines underneath. They're both brackets, so neither one has it. The only ones that are tricky are these where we've got infinities. Then on number 12, we've got -infinity to -infinity to positive infinity. So we're going to write this. Oops. Sorry guys. We're going to write this where x, or whatever variable you want to use, is in the set such that x is equal to all real numbers. You can write that as a double barred R. So if you've had me before for Algebra 1, then you have seen this before. On number 13, it says write the inequality represented on each number line below in interval notation. So interval notation is how we saw it in the beginning here. So these are interval notation. So on number 13, one of my endpoints is 3. And my other endpoint is going forever and ever and ever. So forever and ever and ever, we write as infinity. The circle is open, so my end is going to be a parenthesis. Now number 14, we've got that our endpoint is 3 on the right, and then -infinity, since we're going forever and ever. Any infinities, we're always going to use a parenthesis, but here we've got a closed circle, so we're going to use a bracket. Then on number 15, we've got two different endpoints. Neither are infinity, so we've got -2 and 3. They are both closed circles, so on both we're going to have a bracket. Number 16, give the domain and range of the function graph below in interval notation. So interval notation is what we were just working in. So the domain is all my x values. For my domain, I'm looking left to right. So looking from the left to the right, I see that it starts here and it ends here. So my domain starts at -6 and it goes all the way to, I think that says 5. Now I need to put the brackets or the parentheses on it. So on this first one, it's an open circle, so parenthesis. This is a closed circle, so bracket. Now when it says range, we're looking up and down. So for range, I'm going from this value all the way up to this value. So on my range, my lowest value is -2, and my highest value is 2. Now this is a little tricky here because it's asking me, is this included? If I have a closed circle, then it is included. Then on the other end, going all the way up to 2, since it is a point there, it is included. So the only time it's going to be excluded is when there is only a open circle. So only an open circle is going to be excluded, and then if there is a closed circle at all or it is on the line, then it is included, and that's going to be a bracket. So we've got a little bit more to do. We're going to determine the domain and the range, and then whether it is a function or not. Oops. So on number 1, the domain is going to be the set of all our x values. So 2, -2, -1, 1, -2. My range is going to be all of my y's. -3, -1, 0, 2, -1. Whether it is a function or not, we're checking is there repeated values in the domain. So are there repeated x values? If yes, if anything is repeated, then it is not a function. So 2, -2, -1, 1, -2. Oops, we've got -2 twice. So because of that, this is not a function. On number 2, we're going to do the same thing. So 2, -2, taking all those x values, -1, 1, -3. The range is going to be all of our y values, -3, -3, 0, -3, -1. So here I see that I've got -3, -3, -3. That does not matter when we're looking at whether or not it is a function. We only care about the domain. So in the domain I have 2, -2, -1, 1, -3. Nothing is repeated, so yes, this is a function. Number 3, we've got 2, -3. We'll just write the domain. So the domain is all of our x's, so 2, -2, -1, 1, 2. I already see that I repeated. So can this be a function? No. And then I'll write the range, that's all my y's, so -3, -1, 0, 2, -1. Now on number 4, domain or x values, 2, -2, -1, 2, -2. Uh-oh. We've got repeated values, so no, this is not a function. We'll look at our range, -3, -1, all of our y's, 0, -3, and 1. Now when we're looking at mappings, we have to determine the domain and the range and if it's a function or not. Mappings go from x to y, so they labeled it input, output. That means if any of these go to more than one y, then it is not a function. So already I see right here that 0 is going to -2 and it's going to 1. So if we wrote out the point, we would have 0, -2, and 0, 1. We can't have that same x twice. So this is not a function. Our domain are all of our x values, so 0, 1, 2, and 3. And our range is all of our output values, our y values, so -2, 1, 2, and 4. Now on number 6, it's the same thing. So we've got this mapping where we've got x to y. Do any of these go to more than one value? I don't see a double arrow. I don't see one that looks like that. So since none of my arrows are reaching more than one y value, I have to double check that none of these values are repeated. -2, -1, 0, 1, 2, none of them are repeated. So this is a function. And then I'm going to write out the domain and the range. I don't have a lot of space. So the domain, -2, -1, 0, 1, 2. And then the range, my y values, -3, 0, 3, 6, 9. So domain and range, domain is going to affect whether or not it is a function. The range will not. Range are my y values. So your assignment are the next 2 pages, but I'm only going to ask that you do, let's do the, let's do the evens. So I only want you to do the evens. And then you'll upload a picture of your homework. Make sure that your name is on both pages. If your name is not included on both pages, then I cannot give you credit. So you're going to upload both of these pages to Canvas as your homework assignment, but you're only doing the evens.